Hey, this is Joe Burnett on the Runner team. I want to share a little proof of concept I've been working on over the last day. It's something I'm calling Uplift, and it's a way to scale down your runner resources to zero when you're not using them. There's a problem that happens when you have a lot of runners that you need to keep active um, for jobs that don't happen very often. You waste a lot of resources. Runners pull their work, so GitLab can't really start them on demand. So you need to keep some active process waiting for jobs. But if you have a lot of different projects, if you have a lot of different configurations and need to keep them separate, then you end up having a lot of idle compute capacity. And this costs money. So the idea behind Uplift is to bring those compute resources down. And when a job shows up, look at the tags and decide what runner manager it's going to need and to bring that runner up on demand. And then after a while, if it's idle, bring it back down again. So you can configure these runners however you want. In this case, I actually configured the runners as runner managers. So here you have GitLab, and off of a webhook is hanging this Cloud Run function uplift. So GitLab's fully hosted, gitlab.com, or maybe you're hosting this yourself, but you don't want any extra compute sitting around. And then this Cloud Run function is sitting there waiting for a call. And as you know, with Cloud Run, if there's no web call at the moment, you don't pay anything. It just scales to zero by default. So you just need one of these, one function for all of your projects, because it's this only job of this little binary here is to bring up the managers that are necessary. So it's just looking at tags and making API calls periodically. That's all. So it's really lightweight. Um, what I've done is I've actually pointed it at two different runner managers. And these runner managers are in a instance group, and I scale between 0 and 1. And the only purpose of these is just to be switched on and off. And so they don't actually do their own work. They have a fleeting plugin each configured for one is configured to run the actual job work in another instance group in GCP, and the other is configured to run the actual work in AWS. So this is also just kind of a demonstration of the flexibility that you can do with the new auto scaling framework, which is not related to Uplift. Um, so yeah, so here's the basic setup. And right now everything's scaled down to zero. Like there's no workers, there's no runner managers. There's only one function sitting there that's kind of idle right now. So there's nothing at all running for my project. So let me show you what my project actually looks like here. Now this is the little bit of code that I've written, and I also hung the demo off of it in the CI/CD. So if I look here at runners, you can see there's two runners, the AWS and the GCP one. These are the runner managers. Last was seen 13 minutes ago, and the other one was seen an hour ago. So they're not running. It waits. GitLab waits for about 2 hours before it actually kind of says that they're offline. But I'll show you here. These are the only instances that I have right now. My development machine, and these other ones that are stopped. And over here in AWS, same deal. No instances. Okay. So I have this one function here, and I'm going to show you, not a lot's been going on with it right now in the logs. Yeah, nothing's happened in the last, 15 minutes. So what I'm going to do is I'm going to start a workflow. So I'm going to come here to my pipelines. Let me show you what the configuration is real quick. It's super simple. Basically, I just have one thing that does hello world from GCP and one from AWS, and they have the associated tags. And so what I've done is in Uplift, I've actually said GCP tag points to this runner manager, AWS tag points to this runner manager. I'll show you what that looks like here in a few minutes. Right now, I'm just going to run this pipeline. And right off the bat, you're going to see that these aren't doing anything, right? They're kind of pending because there's nothing to run them yet. However, if you come back over here to this function, let's take a look at the latest logs here. You can see, yeah, 1457 just now. Uplift Manager GCP is activated by these tags. So what this function will actually do is it'll go grab the job, look at the whole set of tags, and it'll look through all the configured runners that it has, and it'll find all the runners that could possibly run that job, the ones that have all of those tags, and it'll bring all of those runners up because it doesn't really know which one it's going to go to. So in this, you can make it one-to-one if you're careful with the tags, but its job is just to make sure that that job is going to have something to run it. So I'll come over here and let's just see if anything's happening. Oh, looks like both of the managers have come up. So they are now pulling these jobs. Let's come back over here, take a look at this pipeline. It looks like, oh yeah, there we go. So both of these jobs are now with the manager, and the manager is going to bring up the capacity. The run manager is going to bring up those worker instance groups. So if I come over here again, you can see that now there's a worker for this GCP one, and over here in AWS, look, oh, there's even a worker for the AWS one. And this job here, just see, oh, this job ran. Hello from GCP, hello from AWS. So where there was no capacity, now there is some. And this works also if you want to run a large number of jobs too, because of the auto scaling. So you could bring up the manager can pull like 10 jobs, bring up 10 VMs, run all that at once, and then scale it back down again. So I'll show you what that looks like here. You can just kind of, let's just say we're going to do parallel, do 10 of these, and 10 of these, and just kind of see how it scales out. And again, this could be like the first thing that you see. It comes up a little bit slower because, it needs to start the manager and VMs, and then it needs to start the actual worker VMs. But you could actually put these in different environments. Like maybe you could even take the managers and put them in Cloud Run. Maybe you could have the actual work happen in Cloud Run as well to make it entirely serverless. So yeah, let's take a look here. We should have seen those jobs, and it looks like we did. Oh, these things are already activated, you can see here, so it doesn't need to do anything. So let's take a look at our instances, and it looks like, yeah, we're scaling out because I told it just run one job on one VM. Let's just see if anything's happening over here on the AWS side. Looks like not yet. Now, the nice thing is once, since these are my own, instances, and I own these projects, I can reuse them. So I said max use like 100. So as soon as I have this additional capacity, subsequent runs will go much faster. Okay, so AWS is scaling out. Let's just take a look and see how that pipeline looks. The pipeline's running. Looks like GCP already did all 10. That's super great. Looks like AWS is mostly finished. Yeah. And that just sort of took this time, since the managers were already there, it took a lot less time because all I had to do was spin up those workers. So I just had to scale out the workers. So it's capable of not only, is it capable of going down to 0, but it's also capable of scaling very highly as well. So let's just run the pipeline again with the same configuration, and you'll see it's going to run a lot faster because the workers are already there. Each of those managers I've configured with a idle time of 5 minutes, which you can put whatever you want there. And it looks like, yeah, all those 10 are already done. These ones are in progress. Kind of just depends on how long it takes to push a SSH key down there. And there it goes. Now, if we wait 5 minutes, you're going to see all of those worker instances collapse down to 0. Because that's the normal auto scaling. That's the normal auto scaling mechanism with GitLab Runner. I'm using the instance executor with auto scaling parameters. This is a new Docker machine replacement, or it's actually auto scaling for shell. But the Docker plus auto scaling and the instance use the same method. And they use different plugins to talk to these two providers. Now, so the workers are going to go all the way down. The only thing that's not going to disappear automatically are these managers. And the whole idea was that, you would save capacity by getting rid of the managers. That's actually not quite as hard as the scale up problem, because you just need something to look at the managers, and when they're idle for a period of time, just turn them off. So they could idle themselves. And, so basically if they haven't had any jobs in 30 minutes or 10 minutes or whatever you want, they can just go to their own instance group and just say resize to 0. I just didn't have a chance to actually do that part of it. So here, I could just do this, manually. And I'll just resize those managers back to 0, and then everything will go away. So that's the idea. That you can actually set this up pretty easily without a whole lot of effort. Let me show you what this code actually looks like. And I say it's not a whole lot of effort, but let me actually show you what was involved in orchestrating this. There was a bunch of work that I did to set up those runner managers. That is just making the images, configuring them with the right permissions to be able to scale those 2 instance groups. And there was a bunch of work that I did to set up the worker templates so that they had everything they needed to run jobs. And that was really the bulk of the work. And that's the sort of Terraform scripting that you already have to do to set up these runners. And the only difference is, instead of a single VM for the manager, you just put it in an instance group so you can make it come and go from a template. The only other thing that I needed to do was actually listen for the webhook. And so this little Go binary here, it's like 163 lines. Basically what it does is here, you can see that I've configured it with a mapping of tags to runners. So it's like, okay, these runners are tagged with these things. And then this is going to be associated with the jobs when they show up. And you would probably put this config either in a file or in your Terraform script that actually sets up Cloud Run. Or you could put it in an environment variable or whatever. And of course, it needs to have a token to access GitLab. And I just used this type to deserialize the job event, because the thing I want to read is I just want to kind of check, make sure I have everything I need, extract the ID. I turn around and I get that job from GitLab, and I look at the tag list. And down here, I basically just sort of go through all the tags of that job, looking at all the runners, and just say, okay, you have this one, you have this one, you have this one, and return a list of potential runners. And then I just activate all of those runners one by one. And activating is just calling out to that instance group and setting the scale to 0. To 1 to bring it up. Idler would basically do the same thing, except for it doesn't have to care about tags. It would just be like, if you haven't processed a job in 30 minutes, set the scale to 0. Because, it's fine if you do it and then a job shows up, because that webhook's can turn right back around and bring you back up again. Yeah, so that's the idea. Thanks for watching. I hope it was kind of interesting. It was a lot of fun to build, and yeah, it's a proof of concept. I just wanted to show you concretely what the idea would look like. If this is interesting, if this is useful, please leave me a comment in an issue on this repository. This is in my personal account here, Joseph Burnett, Uplift. It's not supported by GitLab. It's not a GitLab project. It's just an idea. You are welcome to grab this code and like do something with it useful, to use it as inspiration, or or not. But yeah, that's the idea. Thanks for watching.